So what we're learning today is a continuation of what we learned last class with inequalities, but today is shopping math. Woo! So y'all really lacklusterly woohoo, but I love it. Okay, so let's pretend that you look at Black Friday deals or something like that, and you see an advertisement like this that says all holiday items priced $30 to $100 are between 20 and 50% off. As a consumer, which means we're the people shopping, we're the consumers, we think, yay, a sale. But the business people of Target, and if you ever plan to own your own business, you actually have to think of this scenario like this. Okay, this is way more complicated than what we're going to be doing today, but I want to show you the end goal. This is something that Algebra 2 would do. We're going to be doing something like this, but way simpler. This is a mathematical representation of that sale. We're saying that items, items, are between $30 to $100. So I know that these are items that are bigger than $30. That's greater than. And less than $100. So I'm going to go to the left or below that one. I also know that these items are going to be between 20% off and between 80% off.
But it's not a rainbow. But it's still pretty.
Okay? What do you now notice about that center region?
It has all the colors.
It has all of the colors. This is called a system of 4 inequalities. That's some crazy stuff right there. We're only going to be doing systems of 2 equalities in real life, like today in class. But in real life, you have some really complicated inequalities. We need these items to be bigger than 30, less than 100. To be 20% off or 50% off. So this region right here in the center, this region right here where all of the colors overlap, represents my sale. And if I'm a business person that works at Target and I'm trying to figure out what to price different items, I'm going to need to understand this region where all of these inequalities overlap. But that's real complicated, okay? That's like business math. We're just going to be doing Algebra 1 today, which we're going to be looking at equations that look more like this. We're going to be doing systems of linear inequalities. If you would please highlight the word system. We used the word system when we did equations. What happened when we had a system of equations? It was what? It was a set of multiple equations. There were multiple options for what a solution looked like. I'm crossing my arms. How many solutions was this?
1.
How many solutions was this?
9.
My arms are parallel to each other, so there's no solution. How many was this when they're on top of each other? 3. Infinitely many solutions. Now, for inequalities, for systems of inequalities, we're not really going to be looking at the place where they intersect. We're going to be looking at the place where their shadings intersect. So for a system, we are still going to have 2 or more inequalities, just like we had 2 or more equations whenever we were doing systems of equations. These are still going to be graphed in the same coordinate grid. But when we're looking for that solution set, we're no longer just looking for one shade or one place where they overlap. We're looking for the place or the coordinates that are in the double shaded region, the super shade, the double shaded region. But still not on what kind of line?
Dash.
Yeah, we still cannot have it on a dashed line. Okay, so it's basically, we're taking what we did last class, which was graphing lines and coloring. We're just going to do it twice at one time, and we're looking for our solutions to be where that double shaded region is, where the shading overlaps. Okay, so let's look at this first one. There are 4 regions, okay? Regions, it's not an official term for it, but there are essentially 4 regions on this graph. I'm going to label them up here. Don't label yours because it won't show up in your pencil. But this is region 1. Do y'all see that? Region 1. I just am choosing to name that one region 1. This is going to be called region 2. I'm using Roman numerals. Then we have region 3. And then we have region 4. Which region has all of the solutions?
Region 2.
Where's the double shade?
Region 2.
The double shade appears where the shading overlaps. This is region 2. This has no shading whatsoever. This has 1 half plane of shading. This has 2. This one back is having 1. So we're looking for where the double shade appears. That's where the solution set is. So it's region 2. First thing we're going to do on here is kind of work backwards. We're given a picture, so we want to write the inequalities that go with this. To write an inequality that goes with it, we just have to fill in the formula y, some sort of symbol, mx plus b. What does the m stand for?
The slope.
The slope, or the rise over the run. We're just going to count and make a fraction. What does the b stand for?
Your y-intercept or your initial value.
Very good. My y-intercept or my initial value, where it begins on the graph. Now, since I left this box here, this is where those 4 symbols that we learned about last time might go. What is this symbol called that I just wrote up on the screen?
That's greater than.
Greater than, because it looks like your right hand. What about this one? Less than, because it's a left hand. What's this one called?
Greater than or equal to.
And the last one?
Less than or equal to.
You just have to pick which one of those goes with it. And we find that out by looking at the line to see if it's dashed or solid. And we look at the shading to see if it's above or below. It'll help us pick the symbol. Okay, I'm going to start with the solid line. Okay, that's the one I'm looking at first. Where does the solid line cross the y-axis?
4.
4. This is right here, y-axis. It crosses it at 4, which means my initial value, or my b, is going to be a 4. I know it's going to be a plus 4 at the end of my equation. To find the slope, we just find 2 points and we count the rise and run in between them. So if I go from 4 to this other point up here, how much did I have to go up? 3. And I went over 1. So my slope is rise of 3, run of 1. 3 over 1, but I can just write that as 3. So I'm going to have 3 next to an x in this equation. All I have to do is pick the symbol that goes in there. And we have to look at the picture. This line was dashed. So is it, or sorry, this line was not dashed. This line was solid. So is it going to have the line underneath the symbol?
Yes.
Yes, okay. Then we need to look at if it was above or below. Was this shaded in above it or below it?
Below.
Below it. So which symbol do I give it? Less than or greater than?
Less than.
Less than. There's the inequality that represents that part of this system. It's solid, so it's got the line underneath it. It's below, so it's less than. And we found the slope and the y-intercept. Putting together literally everything we've been learning so far. It's pretty cool, right? Okay, let's look at the second one. Where do I begin for the dashed line? 2. So I know it's going to be plus 2 at the very end. And if I find another point, all I need to do is count the rise and the run between these 2 points. So to get there, I would go up, how many? 1. And over 2. Up 1 and to the right 2 gives me a slope of 1/2. All we have to do is choose a symbol. This one is dashed, so will it have the line underneath it? No, it's not going to be or equal to. And this one, is it shaded above or below? Above, so that's bigger or greater than. Y greater than 1/2 x plus 2 is the inequality that represents that shaded region. So this right here, the green and red line that I wrote on the screen, that is the system that is represented in this graph. That is the system represented here, matching up the slope, the y-intercept, and the shading and line. Okay. Now we do need to know where solutions are in this shaded region. So all I'm looking for when I'm asking you to give me 3 possible solutions is for points or coordinates that are in the super shade. I'll give you one and you got to give me the other ones. Okay. The coordinate right here, which is 3, 6, is one of the possible solutions in the solution set. Can you write down 2 more possible solutions in that solution set? I'll give you like 20 seconds. Yes, solutions are in the super shade, which means it has to be in that double shaded region or else it does not count as a solution. Give you another couple seconds to write down another 2 solutions. All right, someone give me one of the ones they wrote down. 4, 2. So over 4, up 2, that's right here. Is that what you meant?
3 over 3 and 5.
Do you mean 2, 4? Yeah. So over 2, up 4. Oh yeah, 2, 4. So this is not one. 2, 4 works. Because over 2, up 4, that's in my super shade. Give me another one. 3, 7 would be right here. Yeah, that's in the super shade. That works. Okay, I know there's like a bajillion more because legitimately there are a whole lot more. If we zoomed out on this graph, if we could like pinch and zoom out, it would continue to be double shaded for a long time. So there's like a lot of solutions here. Those are just 3 examples. Okay, but there are what we like to call tricky solutions and tricky non-solutions. Can anyone guess what I mean by tricky? Like, what do I mean when I say tricky non-solution? Hard?
It can be complicated.
They can be complicated. So if I'm looking for some tricky solutions and some tricky non-solutions, what I'm looking for is the answer choices they might give you to try to think that you don't know the answer, okay? One of the tricky solutions, so this is okay, is the coordinate, ready for it, 0, 4. Why is that considered a tricky solution?
Because it's
on the line, but
it's
it's
in a
also a
widget.
solid line.
Like the what or
It's a y-intercept, but it's in the shaded region, yes, but it's on a line. Is that line okay?
Yes.
Yeah, solid lines are okay. So that's a tricky solution. That one still counts. What do you guys think a tricky non-solution would be?
0, 0.
So a dash, if it was on a dash line.
Yeah, if it was on a dash line like 0, 2, that's a tricky non-solution. I'm sorry, you can't really see with the screen. I just plotted a point right here. Okay? This is 0, 2. It looks like it's in a shaded region, but it's on a dashed line. Do dashed lines count? No, that is a tricky non-solution. That does not work. Bonus question. If I had a point right here, do y'all see my little cursor? Right here where those 2 lines cross, is that a solution?
yes, because they cross.
It's not in the.
But no.
It's not in the shaded.
Because it's on the dash line.
Because it's on a dashed line. Guys, the dashed line takes precedence over the solid. This point would not work because this line happens to be dashed. If they were both solid, then this intersection point would be okay. But if either one of them is dashed, or if both of them are dashed, the point where they intersect does not count as a solution. That would be what we call a tricky non-solution. Anytime it's on a dashed line, period, point blank, whatever, it does not count. Cool? Awesome. Any questions about what it's going to look like when we graph a system of inequalities? No. Here's what I want you to do. I want you to go to your Desmos, and I want you to type in these inequalities just as they're written on the page. Now, we're using test mode. Please make sure you're in test mode. Go ahead and type them in. Something's going to happen, and I want us to figure it out. Type in the equations just as we have them written on our paper. I want us to figure out what's wrong with this on test mode now, so you know how to use your Desmos to help you. Yeah, everyone's panicking because what's happening?
It says error.
It says error. Okay, so that little triangle with the exclamation point in it, hover your mouse over it. So like pull your little mouse over to it, and you're going to hover. Above that symbol, it's going to say plotting inequalities is disabled. So plotting inequalities is disabled on the graphing software that you get to use on the STAR test, on my test, and on quizzes from here on out. But plotting equations is not disabled. Change those inequality signs to equals. You're going to get the lines that go along with this inequality system, but you're not going to get the shading or the dashed solidness. They're just going to be regular good old-fashioned lines. So what you would type in, basically what I'm saying, is this. This is a system of equations that you can then go back and think, okay, I know that this green line needs to be solid and below. So whatever I typed in for that equation, I'm going to visualize that the lower half of this graph is shaded in, even though it's not. When I graph the second one, I know that this equation, the red one, has to be dashed and above. So whatever it graphs for that one, I need to make sure that I visually see it being above. So whatever it gives you, you're going to have to be able to visually tell what's happening with your brain because you've memorized those 4 inequality signs for me. Does that make sense? Okay, so Desmos you can use to check your work, but you're going to have to still remember those 4 symbols. Don't get reliant on it because you are capable of doing it yourself. Speaking of doing it yourself, we're going to go to the inside of this packet, and we're going to do one of these systems by ourselves. And by ourselves, I mean without technology, but like I'm still going to do it with you. We're going to graph this system of inequalities by hand. It's going to be fun. Can I graph this first one right now?
No.
What's wrong with it? We don't have y equals. The y is not by itself, so we have to solve for y. So what is the first thing I need to do to start solving for y?
How
How do I move that x to the other side?
It will be a One positive 2x.
Very good. My inverse operation from subtracting 2x is to add 2x to both sides, but the negative 6 and the 2x are not like terms, so instead of combining them, I just write them down next to each other. Did I finish solving for y? No. What's left to continue solving for y?
3 by each of the numbers.
Cool. I'm going to divide 3 because 3y means 3 times y, so get rid of times. I just divide. Do I need to flip my symbol here? No. Why do I not need to flip the inequality sign? Yeah, okay, it's only when you divide or multiply by negatives that you flip-flop that sign, right? So we're just going to have y greater than 2/3 x minus 2. Consult your calculator or your brain if you're like, Miss Cookley, where did you get those numbers from? I did the math. Okay? Based on this equation, now that it's solved for y, that I've highlighted in red, what is the slope?
2/3.
Ooh, how do you actually say that? 2/3 or 2/3. What's the y-intercept?
-2.
And then based on the symbol itself, is this equation going to be dashed or solid? Dashed. Is it going to be above or below? Above. This is going to be a dashed and above line with a slope of 2/3 and a y-intercept of -2. So I begin at -2, beginning on the y-axis at -2 to create more points. How do I go from here and make more points?
You go up 2/3.
Very good. Up 2 to the right 3, because that's my slope. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Till I feel like I can confidently put my ruler down, if I can identify where I put my ruler down. Oh, here it is. And do I need to make this one dashed or solid?
You can make it dash.
Dash. Okay, cool. So I'm going to dash this line. I'm really bad at drawing straight lines. Okay, there's my dashed line. And I'm going to shade in which direction? Above or below?
Above.
Above. So I'm going to color in above. You know what? I'm going to color in a highlighter.
Do we color in our highlighter?
You can if you'd like, or you can use pencil. Now, I just graphed one inequality, but today we're graphing systems of inequalities. So I'm not just done right now. What else do I do I have to go in here and graph on the same place?
The second inequality equation.
Oh yeah.
Ooh, the second inequality equation.
It's already done.
Very good. Kayla just said this is already done. This is already in the format where we can graph. It's in slope-intercept form. So what is my slope?
1, -1.
-1 or -1/1. Cool. And then what's my y-intercept?
4.
4. Based on this symbol, dashed or solid?
Solid.
Solid. The line underneath it means it's going to be solid. And based on the fact that it's less than, is that going to be above or below?
Below.
Below. Okay, cool. Now we have all the info we need to graph this one. We would begin where?
4
4, is that right here on the y-axis, or on the x-axis?
on the y.
On the y-axis, we start at 4. 1, 2, 3, 4. Oops, I was going to make it green. We start at 4.
You want to go down 1 over 1.
How did you guys know over 1?
Well, you always go.
Because it's a fraction.
It's a whole number, so to make it a fraction, I'd put it over 1. And it's always to the right. So the down takes care of the negative. Always jump to the right. Down right, down right, down right, down right, and on and on. This time, once I feel confident about drawing my straight line, I pop my ruler down. This one can be solid, so I don't have to think as hard. Started at 4, went down 1 right 1, down 1 right 1, until I drew my straight line. But I do still have to shade in. Which direction am I shading?
Below.
Below. So which region has the double shade?
2.
Well, I'm gonna number them for you now because they're not like quadrants, so they don't always stay the same. But I'm gonna name this one this time, not Roman numerals. I'm gonna name this one A. I'm gonna write it on here. I'm gonna name this one A, this one B, this one C, and this one D. Which one has all of the solutions in it?
B.
Huh?
B.
Not Bob.
Hey.
Annie has all of the solutions. Okay. This is where Antonio has all the solutions. That's where they overlap. That's where the systems of equations overlap. So that's where all of my solutions are. Yeah? So this one's a little bit easier to do if you have two colors, or if you do at least a color and then lead with your pencil, so you can at least know which direction you're going to be shading for each one. It's kind of hard when you have only one type of lead or one color, so I apologize for not telling you to do that. Okay? Give you a second to catch up. So since we take multiple choice tests in this class, there will be one on your test, by the way, that you're taking next class that's going to ask you to do this by hand. Okay? So if you want two highlighters when you take your test, you can actually highlight and then, whatever, get your supplies. But what a lot of the multiple choice questions are going to look like are skills 2 and 3 that are on your notes. Skill 2 asks the question, which graph best represents the solution set of the system of inequalities below? So this time it doesn't want you to actually graph it. It wants you to figure out which graph is correct. Okay, so we're looking for the double shade that is correct. Let's start with the first equation, because the first equation is written in the format that I can use. What's the slope of the first equation? 3 over 1, and its y-intercept is 5. Based on its symbol, dashed or solid?
Dash.
Above or below?
Below.
Is greater is above. Okay, cool. So here's what I want us to look at. If you zoomed in on these graphs, and I know yours didn't print very well, we will make sure that on tests that they're bigger, or at least you can zoom in on them. This is 0, so here's 2, here's 4, that means 5's right here. Would this graph cross at 5?
No.
If I zoomed out, it wouldn't?
Yeah.
If this is 2, 4, this is probably 5, wouldn't it probably cross there? Okay, so what I'm pointing at right here is this dot about there. And if I just let it continue up there, it's a dashed line through 5. Is that what we want? A dashed line that goes through 5? Yeah, we said this one should be dashed, and it goes through 5. I also want this to be shaded above. Is that shaded above?
Yes.
Okay, that looks pretty good. We can hang on to answer choice A. Let's look at answer choice B, though. Here's the line that goes through 5. Is it dashed?
No.
No. Is it shaded above? No, this one's shaded in here below it. So is answer choice B going to be correct?
No.
No, it's definitely not right, because even just looking at 1/2 of the answers, I can match up what I know about these inequality signs and know that that system is not correct. Since I only have 2 answer choices, obviously it's A. I don't even have to finish this problem. But I could. I'd solve the other equation for Y and match up those inequality properties with it as well. Okay. The second way that a multiple choice test that you're going to take next class may ask you a question about system of inequalities is skill number 3. Look over at skill number 3. It says, which of the following is in the solution set of the system of inequalities? When I'm asking you for something that is in the solution set, what am I asking you for?
In the shaded region.
In the what kind of shaded region?
The double shade.
The double shaded region, because remember, systems are going to have 4 different regions, and we're looking for the double shade. That's where solutions exist for this. Okay? On this skill, I really need you to pay attention to what I'm asking you to do, because I'm going to show you how to visually solve these problems using Desmos test mode, which won't show you the shading. Can I graph this first one?
Yes.
Can I graph the second one? Okay, let's solve the second one for Y. What's the first thing I need to do to solve the second one for Y?
You need to move the x, and it will become -1x.
Very good. So I have -3y less than or equal to -1 or -x plus 10. To continue solving for Y, what needs to go away?
So you divide by 3 on each of them.
Now your spidey senses should be tingling because you just divided by a -1. What do you need to do?
You need to change the sign.
Bloop, flip that sign over. It flips over to being the opposite. It's now greater than or equal to. This is Y greater than or equal to 1/3 x minus 10 thirds. Consult your brain or your calculator if you're like, where'd you get those numbers from? I did the math.
You did the math.
I did the math. Okay. Is this one now in a format that I can graph?
Yes.
Oh, I have two equations that I can graph. Let's use our graphing tool to look at it. Because I wasn't provided with any graph paper on this, so like I could do it by hand, or I could use graph on Desmos to help me. So go ahead and type those into Desmos. But instead of the inequality signs, what are you going to have to put there instead? Okay, please do that. Type those into your Desmos and use equal signs instead of inequalities. We will come back to the paper here in a second once you get it typed in to talk about what region we're going to be looking for. Okay, now that you've got it typed in, look back at these equations on your paper. The top one, based on this symbol, dashed or solid?
Solid.
Oh my gosh, it does not have the line underneath it. Dashed. And since it's greater, is that going to be above or below?
Above.
Okay, look at the second one. Based on, that one would be solid for sure.
Solid and above.
And above. So we want to make sure when we're looking at the equations that have shown up on our graph, since it doesn't show me the shaded regions, I need to visually see above, above. And I also need to make sure that I know that the graph that goes through 5 is dashed. The graph that goes through negative 10/3, which is like 3.3, that's solid. Okay, I'm not going to be able to show you on the screen with the equations at the same time, so you just have to believe me that this works. We're going to type in now each of the answer choices, bloop, 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 and think about which one shows up in the correct region for us. The region that is both above and above both of those lines. Let me cut over and show you. Yeah, based on the fact that D was the one that showed up in that visual shaded region in my mind, I'd cross out the rest of them. This one was on a dashed line, so it didn't count. So I eliminate that one. And 6, 2 is the only one in that solution set. Okay, just to make sure we understand what's going on, you guys have number 2. If we can get number 2, we won't do number 3. And we'll be done with notes for the day, and we'll go back to playing games. For real games. Let's see number 2. Do everything we just did for this one. I want you to do for this next one. Now, I had a couple people earlier ask me, Miss Quigley, you said it had to be solved for y, so this second one won't graph on Desmos. This one actually will. Vux lines still graph. So Hoy and Vux lines, x equals and y equals only, those will graph. Okay, let's take a second and work on this one. So to answer Kayla's question, since we didn't do this on the screen, based on these symbols, these would be solid and above, and then solid and below. Which in this case, below, since it was a Vux line, here's my Vux line and my Hoy line. We wanted it to be above the Hoy line and below or to the left of the Vux line. So then we knew that this region over here was where my solution had to be. The only answer choice that showed up there is answer choice B, so we could eliminate the rest of these. Woohoo! Go Bob, Billy, Baxter. Billy Bob Baxter. Sure.